Hello, everyone. Thanks for joining us for our next live session. I'll be your producer for our session, but before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer. Our session is being recorded. It will be available to view on demand right here on the Microsoft Reactor channel. With that, I'll turn it over to our speaker for today. Thanks for joining us.
Hello, hello.
Hi, everybody.
Thank you, everyone, for joining.
Hi, my name's Anthony Shaw. I'm from Microsoft. I lead the Python and AI advocacy team. And with us today is also Stephen McCullough from NVIDIA.
Yes, thank you. Hey, everyone. My name is Stephen McCullough. I am an AI solutions architect with NVIDIA. So that means that I get to work with Microsoft on implementing all the latest, greatest AI technology into Microsoft and Azure specifically. So Microsoft and NVIDIA obviously have a very strong partnership, and we are working in close partnership to power the next generation of AI through both NVIDIA's accelerated computing platforms as well as Microsoft's global cloud infrastructure. So this webinar series is a big part of that partnership. Anthony and I are here to show users just like you how to best leverage the magic of Azure and NVIDIA together. So make sure to tune into the series as we explore all of these great integrations and show you how to apply them in the real world.
Great. Thanks, Stephen. So our agenda today, welcome everybody who's tuning in from the time zones in Asia Pacific. I'm talking to you from a very hot Sydney today. So our agenda this afternoon is to talk about what open models are, how you can run them locally. Stephen's going to talk about NVIDIA NIM, and then we'll talk about how that is related to Azure Container Apps, so how you can run NIM in containers. We're going to show you that running in the cloud, so running an open model in the cloud. Talk about agents, and then going to give you some demos towards the end of some of this technology working. So yeah, this is kind of our agenda for today. We've got about an hour to get through things. And if you do have any questions, please post them in the chat. We'll kind of try and answer those as we go through, or if we have time at the end, we'll try and get back to you at the end. So before we kind of get stuck into the technology, we want to talk about open models just briefly. So this kind of idea of open models is a little bit different to open source. Sometimes there is an overlap, but an AI model essentially is represented by lots of different things. There is the weights themselves and all the parameters that are involved with that model. There's the data that goes into the model, the training data, and there's also the sort of configuration and how you run the model. So if you're familiar with production models that you would run, such as Claude models, OpenAI models, these are proprietary, these are closed models which are hosted on their platforms. Some of those can be run on Azure today, OpenAI models in particular. And we also have another class of models which are open models. And these are ones where the actual weights themselves, you can download the model and you can run that model on your own hardware. This is not quite the same as open source. You don't necessarily have access to the code that they use to generate the model. You mostly don't have access to the training data to reproduce the same weights. But in terms of the actual cost involved in building an AI model, most of the cost is on producing and like training the model itself. So you can basically download a model that's been tuned and set up, and you can run that model on your own infrastructure. And if you want to, you can also fine tune the model. So in particular, some of the open models have been sort of retrained for different languages, for specific scenarios and stuff like that. So this access to technology is something that's really exciting. It's kind of really picked up in the last couple of years with AI models in particular, how we've got more and more open LLM and small language models as well. So some of the benefits are that you've got more flexibility into how you run them. So you can optimize them to run on particular hardware. You can optimize them to have specific behaviors, for example. And you can also have more control over where they are run. So if you have a very specific requirement, you want to run them on a secured network, for example, then you can do that. One example, actually, on a much smaller scale I can think of is that some of these small open models are quite popular in home automation. More and more people are actually running AI models in their house to do automation of their devices and stuff like that. If you've got any IoT, that's something I'm quite interested in. So I'm playing with, trying to get some open models running in my garage at the moment to hopefully automate some of the stuff I have in my house. Some popular open weight models that you may have heard of would be the Llama series from Meta, the Phi series from Microsoft, DeepSeek, and Lava. DeepSeek and Quen kind of come out the same lab, Mistral, as well as Gemma, which comes from Google. So these are some open models we have available to us today. The one we're going to focus on today is the GPT OSS model. This is from OpenAI. It's quite a recent release, actually, this particular model. There's two sizes of the model. So in terms of the number of parameters that you have available, there's a 20B, B standing for billion, and 120 as well. So depending on how much hardware you have, limited to both the memory and the GPU you've got available, you'd pick either the 20 or the 120. In terms of parameters with models, the more the parameters, generally, the better the performance of the model. Although with some techniques like quantization, you can scale them down to smaller sizes. GPT 120 and 20B are excellent models at particular things. One is tool calling. It's one of the best performing tool calling open models. They're also very good at reasoning, so you can give them some fairly complicated questions for them to work through. Now, I'm going to switch to, if you wanted to run an open weight model locally, then there's some software you can download. Yeah.
Sorry to interrupt you. For our end, it's still showing the title slide. Do you mind sharing your screen in maybe a different way?
Okay. Sorry about that.
Yeah, no worries. Now? It's always tricky. Hey, perfect. There we go. Yeah, it shows us the running open weight models locally slide.
Okay. Sorry, hold on a second. Okay, can you see that? And if I go...
It's still showing the slide for us.
Okay. I'm going to get to the demo now. That's right. I'm going to switch to the demo anyway, so let me just do that. Sorry about this.
Yeah, no worries. Take your time.
Okay. No, I'm going to stop sharing. Can you bring up the slides, Stephen?
Yeah,
I'm going
absolutely.
to try and all the windows have become unresponsive on my side.
Yeah. Isabel, do you mind changing to my screen?
Thanks.
All right, there we go.
Yeah, I think it's really better if I don't present the slides from now. Okay, so yeah, there are some inference engines that you can download to run open models locally. One of the popular ones for desktop users is Ollama. This comes with a GUI available to you. And it also comes with the tools to download the models and pick the right model depending on the hardware that you have. So yeah, that's kind of where I wanted to stop off. But one of the challenges with downloading and running open models is that you need quite a lot of hardware to run them. You can run AI model inference. So inference is the process of actually giving it an input. So that's your question or your prompt, and the AI model calculating and streaming back to the answer. So we call that process the inference cycle. You can do that on a CPU. But for most production models, you need a GPU to do inference. And most people don't have data center GPUs on their desk or available to them. You can use some gaming GPUs, but generally the performance of those is not particularly optimized for AI models. And especially in laptops, you'll find that when you're running some of these training models and things like that locally, you'll see lots of different performance issues crop up on the desktop as well. So, great. And then next to you, I think, Stephen, the next slide.
Yeah, sure thing. So like Anthony mentioned, we can use a variety of different inference engines to run models, but whenever we start thinking beyond, just test or demo deployments, and we start thinking more so at the production grade enterprise level with scalable, high performance AI models, there's a lot more components, a lot more features that need to go into that. So you need inference engines, of course, you need health checks and quantization and API management and so on down the list. There's so much that needs to go into these models to really make them production grade. So NVIDIA really saw this complexity and took it head on to solve this problem by creating what's called NVIDIA NIM, or NVIDIA Inference Microservices. Really, a NIM takes all of the microservices that you need to run AI at high performance and at large scale, and it encapsulates all of these microservices into a single Docker image. So if you used Docker before, you're probably familiar with how portable it is and how easy to use that Docker is. Really, you just run, a Docker run command, and boom, you have a server or, any high performance system up and running just pretty much immediately. So NIM makes use of that portability and flexibility of Docker and introduces all of these high performance optimizations for your AI model into NIM. So when we talk about NIM, we're not just talking about the AI model, but we're also talking about the microservices around it. So this slide kind of shows all of the different pieces that go into it. So of course we have the AI model itself, which might be an NVIDIA model, like let's say a Nemotron model. It might be a, third-party open source model like GPT OSS, for example. And the NIM has that LLM. It has the inference engines like TRT LLM, also VLLM or SGLang, and some other NIMs. It also introduces Prometheus metrics. So that makes it really great to plug into your Kubernetes ecosystem because it has all of these metrics sort of baked in and able to be scraped. And of course, the flexibility of Docker allows you to, run this in so many different environments, container apps, of course, Kubernetes, VMs, bare metal, et cetera. It's all capable of running NIM as long as you have a supported GPU and Docker. So, what does this flexibility and portability and high performance do for us? What's the real benefit? Well, whenever you are working in an environment where you need high throughput and low latency AI models, NIM is very effective at that. Its TRT LLM inference engine is optimized for high performance. And each NIM is really tuned to provide extra sort of performance tuning depending on the AI model inside that NIM. So whether it's a world model like Omniverse, or it's a vision language model, or a LLM, NIM is going to come with that AI model inside with performance optimizations baked in. And of course, the portability and flexibility of Docker, like I mentioned, allows you to run this in just a huge number of environments. Allows you to run it Kubernetes, container apps, VMs, bare metal, etc., allowing your business or you as a independent developer to really be very flexible with how you want to run your AI models. And like I mentioned, the flexibility of NIM is just one of the best parts about it. Within NVIDIA NIM, there are over 170 different models that you can choose from. 40 different model types, like I mentioned, LLM, VLM. We also have protein folding NIM, and of course, world model NIM like Omniverse. And then the platforms that you can run it on, of course, again, are very numerous. So I'm going to pass it back to Anthony to talk more about the platforms and specifically Azure Container Apps and why container apps make such a good platform for running NIMs. Oh, Anthony, I believe you're on mute right now.
Yeah, sorry. So you have to go to the next slide. Great. So Azure Container Apps are one of the platforms that we have on Azure for running containers on the cloud. In terms of the options, there's sort of a full scale, which is Azure Kubernetes service if you want to have full control over your Kubernetes environment. We also have Azure Container Instances, which are sort of like again more sort of a lower level. You just want to run a specific container. Azure Container Apps basically wraps up a lot of the management of the container and the deployment cycles. So if you just have a Docker file and you have a container image that you want to publish onto the cloud, we handle the running of that for you. So you can deploy your container image directly onto Azure with nothing else but a Docker file, or if you've built that image locally, you can deploy the image directly onto Azure. So we manage the cycle in terms of keeping different versions or revisions of that image. We also manage the way in which that container can be scaled horizontally as well. If you've got several containers, each maybe in microservice environment, each doing different things, you can also have the networks, and we'll manage the virtual networking for you. We also manage things like network ingress. So typically, a lot of Docker containers or Docker images in particular have a lot of ports exposed, and generally only one or two of those you actually want to run on the network. So we have basically the ability to give you full control over what is exposed to the network. And then if you want to bridge that onto the internet, or if you want to keep that on a private network and then just have that communication between the containers themselves. So we also have full control over the security. So who's got the ability to publish images, or if you want to have full trust in scanning when you publish the images through only from CI/CD, for example, you've got that as well in Container Apps. So in terms of the stack, I think of Container Apps as being you have an application which is already containerized and you want to deploy and run that on Azure, and then we'll handle all the parts basically for you in terms of like running the network, the security, all the bridging and so forth, as well as the scaling capabilities. And one of the big benefits of that, because there are other app platforms, there's PaaS as well. You can run VMs if you want on Azure, but you pay for what you use. And this is particularly interesting with what we're talking about today, because if there's one thing that GPUs are known for, probably at the moment, is that they are very expensive and quite hard to get your hands on as well. So I think with GPUs, why this is so exciting is because you can spin up and have access to these data center scale GPUs, and you can use them specifically for the task that you need. You can scale up however many you need for this particular task, and then you can scale them back down all the way to 0. So the next slide. In terms of the architecture for that, so the concepts that we have in container apps, there's the container itself. Then you have replicas, which is the number of places, I guess, that container is running. So if you've got a particular image and you want to run 5 of those, that would be 5 replicas. We can handle the load balancing between them. You can also configure auto-scaling rules. So you can say, based on how much network traffic is coming through, or how many HTTP users, or the CPU load, you can configure the rules to say, I want you to auto scale out the replicas. This is something we've done in this particular application. Actually, we've scaled this out to additional replicas. You also have revisions. So, as you're deploying new versions of the app, you can roll backwards and forwards between revisions, and you can also kind of do phased rollouts as well. So you can gradually transition network traffic to a newer version. And then all of these things wrap up into a container environment, which is where in Azure you'd manage all of the networks and the security and all of the stuff that I've just spoke about as well. And then next slide. So when it comes to the GPU workload profiles, we have a few available to you. And the GPU workload profile is assigned to that particular environment, and you'd make a decision as to what your needs were based on what you need the GPU to do. And Stephen's going to talk about the 2 options in a second. So in this situation, what we've said is we want to run an AI model in a container, and we want the GPU to be attached as part of that container so that it has access to like a full GPU layer underneath the application, and it can run GPU models at the inference cycle directly on the hardware. And then the next slide. So the big benefit of doing this is that we've got 2 essential flavors available to you. So one is the NVIDIA T4, and the other one is the NVIDIA A100. And this, like I already mentioned, we've got a lot more scalability options. So if you wanted to start off with something small, depending on the model you need, actually, one thing we probably didn't cover is when we talked about GPT OSS. Like I said, there are 2 versions of the model. There's a 20 billion model and a 120 billion model. There are also other models on you can get which go all the way up to about 500 or 600 billion. These are huge models that need quite a lot of infrastructure to run. It really depends on the task that you're doing. And one of the great things here is that you can experiment with different configurations. So my advice generally with AI models is to try and find essentially the smallest model that does the task that you need. People tend to jump into the biggest, most capable model without really thinking about what question it is you're giving it or what task you're giving it. And a lot of the time, in particular with OpenAI models, they have such a range of different models nowadays. There's different versions, different sizes, and different types of models with different configurations. And the more you kind of get into understanding which models are good for which specific tasks, the more you can kind of fine tune your hardware needs. And I think this is really quite critical because when we talk about agentic programming, for example, and running agents, a lot of the time you're passing small bits of information to the model to make a decision or to look at context and to process data. And it doesn't need to be a 600 billion parameter model that does that. A lot of the time you can actually do that with a 20 billion parameter model. And that's something we'll demo when we get to the hands-on stuff later. So yeah, that's something I wanted to highlight. And we kind of basically make that available in 2 different versions of this infrastructure. Over to you. I forgot about that slide. Okay, so container registry, Azure Container Registry is the service. When you build the containers, you have container images. If you've ever used Docker Hub, that is a container registry. There is also one on github.com, and there are some other commercial ones you get. For Azure, obviously, we've got different customers with different needs. You would typically use Azure Container Registry because you're building your own application. You want to store those images somewhere and you want them to be secured so some random person on the internet can't download your application and run it themselves. That isn't an isolated environment. You've got full control over the versioning, over who can pull the containers, who can actually download the images. And also, if you want to introduce any scanning in the pipeline as well, that's something which is part of Azure Container Registry. So if you want to look at which software is in the image, which versions, and then potentially if there are any software security issues with any of the versions of software in that image, that can all be scanned in ACR. And then you essentially have a ledger so that in your environment, you know that is running this particular version, which is running these versions of the software. And then if there's a security vulnerability in a particular package in Java or JavaScript or Python, for example, then you know which applications need to be patched and updated.
All right, so now we can jump into, now that we understand, the pieces that go into open models and NIM and the container apps infrastructure, we can talk about, the process that we go through to actually get this up and running on Azure Container Apps. So if you're anything like me, you like to just dive into things and not read the instructions and just kind of figure it out along the way. But I'm here to tell you that, if you want to deploy, your AI model on container apps, let's make sure we have these things all set up first. So number one is anytime that you are using a NIM, that NIM is pulled from NVIDIA's container registry. And to pull from their registry, you just need to create an NGC account. NGC is NVIDIA GPU Cloud, and it's pretty much like the comprehensive hub where you can go to find the software and services that you need for anything relating to NVIDIA and AI and HPC. So pretty much, anything you would need is located at NGC, including NIM. So go ahead and create your account, create your API key, and then number two, pretty important here. So it's important to make sure that you have GPU quota in a supported Azure region. And there's two parts of that statement that we should unpack here. So with GPU quota, right, what does that mean? That's pretty much the maximum limit set on your Azure subscription that you can use in a certain region. And that's what quota is. And we're talking about GPU quota. That's the maximum amount of GPUs that you can use in your subscription in a certain region. So if you don't quite have the GPU quota necessary to run container apps, you can always request an increase in quota. So there's always ways to gain access to the quota you need within Azure. So the second part we should unpack here is the supported Azure region. So serverless GPUs are supported in these 5 regions. So, considering the APAC region that we are, working with currently, Australia East would probably be the best region for the current audience. So within Australia East, you have access to both the NVIDIA T4 and NVIDIA A100 GPUs, which I'll talk about in more depth in just a minute. But yeah, so in this region, you'll be able to deploy both types of GPUs within your Azure Container Apps. The third is just like Anthony was talking about, go ahead and create your Azure Container Registry. this is going to be essentially, you can kind of think about it like an intermediate registry between NGC, which stores like the source NIM container, and your Azure Container App. Your Azure Container App will be pulling images from Azure Container Registry anytime your container app needs to scale or even just get up and running. So you'll need to make sure that your NIM is stored in your container registry. So when we're thinking about the different GPU options that we want to use within our container app, there are a few big questions that we need to think about here. The first, like Anthony mentioned, is the size of your model. So with GPT OSS 20B, that means it has 20 billion parameters. And the size of those parameters depends on the precision. If you're using BF16, which is 16 bits per parameter, that 20 billion parameter model is going to take up 40 gigabytes of space. If you're using FP8 or floating point 8 precision, when you're running GPT OSS 20B, that means that each parameter takes up 8 bits. So 20 billion parameters, 8 bits, that's 20 billion bytes, so 20 gigabytes. So this is just some back of the napkin math that you can do to figure out, how much GPU memory that you need, because every GPU type has its own, amount of GPU memory. So for the T4, for example, it has 16 gigabytes of VRAM. And the A100 has 80 gigabytes of high bandwidth memory 2 and 2E. So obviously the A100 has a lot more memory and a lot more space to run larger models. So that's a big thing to consider sort of at the beginning of this container apps deployment, is the size of the model that you're going to deploy. Now also, you want to consider the trade-off of cost efficiency versus performance. The T4 is excellent at high cost efficiency. It's really great when you look at sort of the inference performance that you get per dollar. That's where the T4 really shines. But if you're looking just for high performance, the cost isn't as important. The A100 is going to be your option there. So these are the two options available. You can really sum it up as thinking T4 is for smaller models, better cost effectiveness. A100 is for larger models and higher performance. Now, whenever we get to setting up our deployment onto container apps, this is really just coming down to 3 big steps. The first is pulling the NIM container from NGC. You'll be pulling it from the NVIDIA Container Registry, as I'll show you in a second. Second, you'll take that NIM container and you'll push it to your Azure Container Registry that you set up. And the third is to actually create your Azure Container App. And I'll show you what that looks like in a second, but you'll configure it to have a certain amount of containers deployed and to pull from a certain Azure Container Registry, which is the one you create. And from there, it'll pretty much just run itself. So I won't go through the full process of pulling the image, pushing it, and creating the Azure Container App, but I do want to show you just how simple it is to get all of this up and running. So these first 3 commands are really just logging into logging into the NVIDIA Container Registry, logging into your Azure Container Registry, and then downloading the GPT OSS NIM from the NGC registry. So this just gets the image the NIM container image onto your local environment. And you don't need a GPU on your local environment to just pull this image, because you're not going to be running it. You're just going to be storing it. These last two steps are just to tag the image, essentially preparing it to push to your Azure Container Registry. And then this last one is actually pushing it to Azure. So once you get here, your container will be completely ready to go. And this is what it would look like. In my Azure Container Registry, I have my GPT OSS 20B repo with my latest tag. So once I have it up here, I can plug this into my Azure Container Apps, and it's ready to go. So whenever we think about actually creating the container app, like Anthony was mentioning, there's a couple different components of this architecture that we need to consider. So the first is your container app environment. This is essentially going to be the associated environment around your container app that's going to command things like your GPU configuration and some other high-level configurations for your container app. The second is to actually add your GPU workload profile to your environment. And this is where you're going to specify if you want to use the T4 or the A100 GPU. And if you end up accidentally working in a region where the serverless GPUs are not supported, or you don't have quota for this, this is where it's going to tell you that it's going to return an error, and it'll let you know that you're not going to make it much further with this deployment. So once you have your environment and your workload profile up and running, that's when we can actually create your container app. So there's obviously a lot of parameters here, but just a few ones we really want to pay attention here to. So first is that we want to pass in that NGC API key to our container app. And that's because the NIM actually needs it to pull down specific model weights depending on your hardware. So we just want to make sure that NGC API key is available to our NIM container. We also want to make sure that we are using the container registry that we set up. And we want to make sure that we are specifying the specific GPT OSS 20B image that this container app is going to use. So once we have that up and running, we can come over to container apps and see that the revision is, or this replica, which is essentially just the actual container, is up and running. So, we're good to go there. This whole process really takes about, 15 minutes or so. And you can get up and running on container apps very quickly. And once you go into overview, it'll show you your endpoint. So if I come back here to my code, now that I have my container apps up and running, I can create a simple health check command just to make sure the model's running correctly with a simple curl command. So if I just create the simple curl command with my container apps endpoint, and I ask it to tell me a funny joke about Saturn. Let's see what it comes up with. So the first thing I want to point out here is that I have 1,000 tokens set for the max tokens. So because this is a reasoning model, it's going to continuously think and use these 1,000 tokens to come up with its final answer. So what I love to see here is how seriously the model takes this task of creating a funny joke, and how much it overthinks this whole process. It's pretty funny. So I'll lower this down to 100 so we can see sort of a more neat output. First of all, I want to point out just how crazy fast that is. That it creates this whole thought process and final answer of about 100 tokens in just a fraction of a second. And this isn't running on a local environment or my own network. This is running in in Azure. So it's just insanely fast how these GPUs can do these calculations and create these tokens. This is running on an A100, by the way. So let's see what the response is. The user wants a funny joke about Saturn. It's a simple request, no disallowed content. We can comply. Okay, good. It's not going to get upset. So here you say, why did Saturn apply for a job at the bakery? Because it heard that they were looking for someone who could roll out the best dough. Saturn's rings are absolutely the best roller in the galaxy. It's always, I think the best part about these jokes is how like corny they are. I think they left good humor out of the training data set. But I just always love seeing the kind of stuff it comes up with. Like I could just look at these jokes just all day. So yeah, this is, just getting your NIM up and running in Azure Container Apps and interacting with it and, the most simple way possible through this curl command. But really, this is just the sort of start of the journey. There's so many ways that we can use this AI model with tool calling and with agents. There's just a whole world. So I want to talk about that for a bit and what we can really do with this model. So whenever we think about AI agents with NIM, let's take a step back and think about what an AI agent really is. The way we at NVIDIA define it is that an AI agent is an advanced AI system designed to autonomously reason, plan, and execute complex tasks based on high-level goals. So, how exactly do we do that? We just saw an LLM creating a joke about Saturn, but how does this turn into executing complex tasks and high-level goals? So let's talk a bit about how agents work at a deeper level. So really the LLM is going to be the brain of this agent, and this LLM goes through a few steps throughout this sort of like agentic cycle you can think of. The first is that once it receives the prompt, it goes into its planning stage. This is the reasoning portion of the agent. This is where it's thinking about, how it's going to approach this prompt. So for example, if we say, plan out a day for me in Seattle, right? This agent is probably going to think, okay, well, I need to find the weather. I need to know what events are going on in Seattle. I need to know where, this person is staying. If they're staying in a hotel, maybe there's some events within walking distance, etc. Lots of things that the model reasons through in this planning stage. And whenever we get to this tool use stage, that's when the model thinks about which tools it should use to gather the data it needs or to execute the task that it was requested to execute. So these tools, this is really where the AI agents, the possibility of what you can do with them just absolutely explodes. Anything from executing code. So let's say, creating a code to create a LinkedIn post, or doing a web search, or doing a semantic search if you're doing a vector database, for example. This really opens the entire world up to this agent and allows you to plug and play pretty much anything that you can think of. So this is, in my opinion, one of the most exciting parts about agents is what you can do with the tools that you give it. So once it runs these tools to, for example, gather the weather in Seattle and the events going on this weekend, it will enter its critique phase. And this is where it looks at these responses, so the weather in Seattle and current events, and it plans out its final response, its final suggestion to you about what you should do this weekend. And this critique phase it's very intelligent here. I was playing around with an agent I had deployed, and I hard-coded my weather tool to always say that it was 20,000 degrees Celsius, which is, of course, just absolutely absurd. And the model realized that there must have been something wrong with my tool, because it received that response of 20,000 degrees Celsius from the tool it used. And the agent said, there's probably something wrong with your tool. I really don't think that it is 20,000 degrees Celsius where you are. So the agent is very intelligent when it receives these responses. It's not just taking them at face value, but actually using them when it's formulating its final response to the user. So this is how a single agent works. And there's so many opportunities and so much cool stuff you can do with it. And then once you sort of take that idea and expand it into an entire network of agents, an entire workflow, this is where just the possibilities really are completely endless. So for example, this is a simple agent workflow where you might have a whole programming team. So if you have your documentation agent and your coding agent that are actually writing the code, and then your diagnostic agent that's maybe doing some debugging, and where each agent is running its own model. So let's say, one agent is running a lightweight model that's maybe 10, 20 billion parameters, where maybe some of the, more the agents that you need more in-depth outputs from are running 100 billion parameter models, 500 billion parameter models. So you can really just, pick and choose how you want each agent to behave and make a very, custom tailored workflow with your agents. So just absolutely lots of opportunity there. And Anthony, do you think you'll be able to show, the demos regarding agents?
Yeah, I'm all ready to go.
Awesome.
Cool. If we switch to my screen now.
Isabel, could you switch the screen over to Anthony's?
Yes, 1 second.
Yeah,
Here we go.
Cool. Okay. Thank you. So once you've deployed NIM into Azure Container Apps, NIM comes with a HTTP API. This API is the same as the OpenAI API. Well, there's a few additional features, but the important thing is it is an OpenAI compatible chat endpoint. And there's also a Llama Stack compatible chat endpoint. So the great thing about this is that I can take this application that we've deployed, that endpoint, so essentially that URL that we have here, and I can drop it into any software stack that it works with OpenAI APIs. And so in this demo, I've taken this and I can use my normal Python tooling. So I can connect to that endpoint as though it were an OpenAI API, even though it's one that we're running in Container Apps and it is running an open model. You'd get the same type of API if you were using GPT OSS, if you were using Llama 3, if you were using any other open model, you'd get the same interface. And this means you can write scripts and tools which operate the same, regardless of which model you've actually picked from NGC to run in the NIM environment. So just as I would with OpenAI, I can ask it to give me a completion response. Something particular about GPT OSS is that because it's such a new model, you typically want to use it with the new OpenAI API, which you'll see as we call it the responses API. And so I can basically just doing that. So if we interact with it, I can send messages backwards and forwards and do just normal chat completion. So that's, that's the most basic demo I can think of. GPT OSS is a reasoning model, and something with the reasoning models that you need to consider is how much effort you want them to put into their reasoning. So on this prompt, if a city starts offering free bike rentals during rush hour, how might different rental durations and locations impact the way people hire? And we can pick like how much effort, which is a parameter to the model, how much do we want to think first, which is the reasoning cycle, before it gives us the answer. So we can basically set that as a parameter. And like Stephen kind of showed, the performance of this model running in ACA is really impressive. This is quite a complicated one. So it's even with a low reasoning effort, low is literally just like it made no effort. But it's come back with, okay, here's my summary of, an attempt to answer your question. And so what you can do as the developer in the scenario is you can have a look at, how much has it really thought through what I've said? And do I want it to pay even more attention to thinking through some considerations? So, with these reasoning models, we can effectively tweak and experiment with the reasoning effort. So if I switch that around to high, it's probably going to take a bit longer. It's going to spend more time thinking about the question that I've given it and the circumstances, and then it's going to come up with a more thorough answer. So if you've ever been wondering, how these AI models have managed to, pass the bar, or they've, done, like math competitions and stuff like that, they're typically reasoning models that have done those types of tasks. And the reasoning on those tests has been set to the maximum level. But in practice, unless every single prompt you're giving the model is like a really, really difficult math problem, I wouldn't recommend setting the effort high in the first place. So you'll see now we've got a longer reasoning cycle, and then the actual quality of the output should be better in that case. So it would have thought through some more circumstances. So this is me basically talking to the NIM model that's been deployed as though it were just any other AI service that I'm consuming. It just happens to be one that is private to us, that's running on Azure Container Apps, and it's running on an open model, and I can switch that model as it were. And in terms of how this is billed by I think it's by the minute or by the hour for the resources that you're using. So you're not paying per token here. So, and I'll come to later, you can scale that up and scale that down if you need to. So if we want to do a research thing and we're going to be working for an hour, then when we're finished, we can just shut that environment off. The other thing that GPT OSS is really good at is tool calling. So GPT OSS is probably one of the best open models available right now for putting into an agentic application. And so in this demo, we're going to use the same client, but I'm pulling in a library called Agent Framework. This is a new framework released by Microsoft just 2 weeks ago. And this is basically a way of programming agents in Python or in .NET, and then running those agents as a workflow. And those agents can be connected with tools, with MCP servers, and you can also plug whichever AI model you want into those. So this is the code. So we've got the function to get the weather. We've got functions to grab activities. These are both just mocked out, so we can just kind of mimic the actual APIs for getting the weather. But this is custom code. And what's interesting about this is when I create the agent, all I'm really doing is giving it a set of instructions. And then I give it a list of the functions in my Python code, which can actually do the specific behaviors. And what the AI does is it uses my comment that I've made in each function to understand what that function does, and then it makes the decision as to whether it needs to call it or not. This is a really simple one, but in practice, we can do things like, draw a graph or look in the database, or there are a lot of MCP servers you can get, for example, online that do things like pulling in additional services, getting up-to-date documentation about different tools and products. So in this demo, we can grab that, and then we can run that agent, and it can say, what do we want to do this weekend in San Francisco? And I can see that it's actually run the function. So it's decided to run the weather function, to run the activity function, and then it's taken all of the outputs from those functions, put it back through the AI, and then it's come up with a nice summary for me to say, okay, since my weather API simulated rain, then it said that it's going to be rainy, so I recommend you visit a museum. Do a museum? That's the one I was going to suggest. That's a great place to go. So it's recommended an indoor activity for me. So if you wanted to plug this into real backends, then you can do that as well. So as an example of an MCP extension to that demo, from Agent Framework, you can pull in MCP tools, whether they're ones which run locally or ones which are remote. Not a lot of people know this, but Microsoft's documentation has an MCP server. So you can actually point it at learn.microsoft.com/API/MCP. You can point any AI at that, and you can ask it a question. For example, does Azure support serverless GPUs? And it's going to go and query the live Microsoft documentation and give you up-to-date responses and knowledge about that as well. So, we have a huge amount of documentation. And yeah, it's coming back and suggesting that I use GPU in Azure Container Apps, which is exactly what we're talking about today. And it says we've got the NVIDIA A100 or the NVIDIA T4. And so this is an example of where you don't have to be concerned about, how up to date is information in that particular model. GPT OSS was trained 2024, late 2024, and so all the information in there is 6 to 9 months out of date. But by using MCPs and a agent framework, you can tell the model to go and find the most relevant information. So this one works with Microsoft documentation. There's also an MCP called Context 7, which you can grab, and it's got a lot of documentation for other services and tools as well. So that's kind of how you can use this AI to actually go and do things other than behaving as a chatbot, which is quite a common scenario we've got. And then I also wanted to show you something else, which is we've configured. So in this environment, we have essentially one replica in Container Apps. So if I go and open up the Container App environment, then this NIM is running on a single container, which is a replica. And how we've configured this is we've got one replica running in that environment. But if we were going to go and throw a load of additional load at this container, it could scale up the number of replicas that are running in that environment. So we can set a minimum here of 1. You can scale that all the way down to 0, actually, and you can set a maximum. And then we've run a load test using Azure load testing to basically go and simulate 50 users all concurrently sending messages to the AI to see how the response time performs. And the cool thing about this is I can see the response times actually stay very consistent throughout the test, but also it's actually scaled up the number of cores that it's going to consume and the number of replicas. So it's automatically going to scale that up to 4 replicas running because it's figured out based on the number of users, it should probably running more replicas in that environment, and it can scale that up. And then as soon as those users have logged off and finished, then it will scale that back down again. So yeah, we'll switch back to the slides. So yeah, I've covered this topic.
Yeah.
Brilliant. Over to you, Stephen.
Yeah, sure thing. I'll close this out. So yeah, Microsoft actually has a walkthrough a tutorial where it walks you through doing pretty much what we showed you here today. Everything from pulling down the NIM and deploying it onto container apps and exploring your deployed AI model. So I highly recommend you go ahead and do that for yourself. We have the QR code here, but also it's very easy to find if you just search Microsoft tutorial, Llama 3, NIM, container apps. It'll be in the top 2 responses. And of course, this is with the Llama 3 NIM. So you can use the Llama 3 NIM, or you can use the GPT OSS NIM. Thank you, Pamela. And you can also browse around the NGC catalog and look for a number of other different names if you want to use them. So lots of different options you can use there, and I encourage you all to experiment around with them and play with them. All right, so that's everything from our end. We do have a second episode up and coming, so definitely check it out. We'll be talking about accelerating AI model performance.
That's going to be great. Yeah, thanks everybody for your time today. Sorry about the technical issues at the beginning. I've been running AI models on my laptop today, so I think it's been struggling a bit with that in the background. So yeah, thanks very much for your time. And yeah, if you have any other questions, please just chuck them in the comments, and one of us will get back to you. And yeah, if you get this running and you've got something to share with us, please also let us know. You'll find us on socials, on LinkedIn or on Blue Sky. And yeah, I'd be really interested to see which models as well you're gonna pick from the NGC catalog. In particular, I'm super excited. I did ask in the chat which ones people using at the moment. I'm excited about Qwen 3 Coder in particular. Like as a smaller coding model that you can automate for specific tasks and activities is a really cool one. So I just want to have a play with that for next week. Thanks very much, Stephen.
Yeah, thank you, Anthony. And thank you to everyone who joined. I appreciate all of the interaction in the comments. This has been great.
Thank you everyone for joining us today. If you guys have any feedback, we do care a lot about providing amazing content for you guys. So if you could just take 5 minutes of your time to scan the QR code that is available on the screen, or if you want to access the link, that is aka.ms/aiapps/10.22. You will be directed to a survey, so you can fill it out, give us some feedback about today's session. And like our presenters mentioned, we do have another session coming up in November, and we'll see you guys soon. Thank you so much for joining. Thanks, everyone.